All right, welcome to today's class. Today we have a challenge on the board. It's on expansion. Okay, the question is easy, but yeah, let's look at this together because yeah, we want to look at the binomial theorem and also the Pascal triangle in solving this kind of challenge. So the question reads: your bracket open 2x plus 3y close bracket to the power of 4. So we have to expand this. So how do we expand this? So if you're new here, this is Online Maths TV where we learn mathematics all the time. Do not forget to subscribe if you've not subscribed so that you get notified whenever we drop amazing video like the one you're about to watch right now. Okay, so let's go straight to the board to see what we have for us today. So here we take selection. Okay, now look at the question here. Here we have 2x plus 3y all to the power of 4. So how do we expound this? Now you know our binomial theorem. If we have an expression of this kind, x plus y all to the power of n, how do we expound this? We can use the binomial theorem, which says that this will give us the summation as k goes to 0 from n, okay, then into your n combination k, then times our first term here, which is x. So we have here x to the power of n minus k times y to the power of k. Remember this? Oh, good. So again, if we go down, because this we can express this here. So we have here the summation of your k as k goes to 0 from n. Then we have n factorial. This is factorial, please. Okay, n factorial all over your n minus k close bracket or factorial then into our k factorial then into or times our x to the power of your n minus k times y to the power of your k. Okay, now from this expression here now, we know the whole of this is just to get our coefficient to the terms we're going to expand from here. All right, now the power of our s, which is the first term, will be decreasing. Meanwhile, the power of y will be increasing. Okay, so this will decrease by -1 and this is increasing by your +1. So how do we now get the coefficient of the terms? If the value is very large, value of n here is very large, so we can get the coefficient of x here from our Pascal triangle. Okay, so from our Pascal triangle, we have your 1 for the power of 0. Then for the power of 1, exponent of 1, we have 1 and 1 here. Then for the exponent of 2, we're going to have here 1. We add this and this together to give us here 2. Then we have 1 out here. Then for the exponent of 3, we're going to have this to be 1. Then we bring this and this together to give us 3. We equally bring this and this together to give us 3. Then we have our 1. Okay, then for the power of 4, because we are having the fourth exponent here, so we have here 1. Then we bring this and this together to give us here 4. Then we bring this and this together to give us 6. This and this together to give us 4 again, and we have our 1. So we are dealing with the fourth exponent. Okay, so from here now, how do we now expand this? All right, so long we know that this will be decreasing and this will be increasing, and we've gotten the coefficient to each of the terms here. This is our coefficient. So how do we now expand this? So this will now give us from here, will now give us here, the first coefficient is 1. Okay, so we have the term here is 2x or to the power of what? We said n minus k. So this will now give us fourth power. All right, then the second term here will be raised to power 0. So we have this to be 3y, the r to the power of 0. Then plus this next term here, the coefficient is 4. So we're going to have this to be 4 into, okay, because we are using this to multiply everything. So let's put it in a square bracket there into your 2x all to the power of 3 dot bracket your 3y to the power of 1. You see this? This is increasing. And you discover something, that the two exponents add together must give you this exponent here. So 4 plus 0 will give you 4. 3 plus 1 will give us what? 4. Okay, so we close our bracket. Then plugs, we come to the third term. So we have here 6 into the square bracket of our 2x all to the power of 2 dot bracket our 3y all to the power of 2. Again, we have 4. If we add this together, right? Close the bracket, then plugs. The next term, the coefficient is 4. So we have 4 into our square bracket, our 2x, the bracket open. This we go to 1, the dot, your 3y, then we increase to 3, the close bracket. And lastly, we have here, what is this? Fourth power, sorry, 1, 2, 3, 4, fifth coefficient here is 1. So this guy goes to 0, so we have 2x all to the power of 0 dot bracket our 3y all to the power of 4. Easy, right? We know 2s to the power of 0 will give us 1, but let's just put it there because we want to go gradually here. Okay, so now let's go down from here. We now have, this is equal to, the first thing we're going to do here is to use the power to open up everything we have here. Let's still keep the constant terms we have here now. So 2 to the power of 4 means 2 times 2 times 2, which is what? 16, right? Because 2 times 2 is 4, times 2 is 8, times another 2 will give us what? 16. So we have here 16, okay, x to the power of 4. This will give us 0. So no need looking at this. So sorry, this will give us 1. Okay, anything to the power of 0 will give us 1. So we now come here, plus, we come to this term here. Here we have, this 3 is affecting this. So 2 to the power of 3 will give us 8. Here we have 3. So 8 times 3 will give us 24. Okay, so let's still keep this guy. So we have here 4 into 24. Okay, x to the power of 3. Then here we have our y, close bracket. Then plus, we come to this term. 2 to the power of 2 here will give us 4. 3 to the power of 2 will give us 9. So we are going to have here 4 times 9. And 4 times 9, that will give us 36. Right? So we have this, the coefficient is 6. So we have 6 into 36. Then we have our x squared, y squared. Okay, so we close this again. Let's come down here. Plugs. This term here now, let's take our coefficient first. So bracket, here we have 3 to the power of 3. So 3 to the power of 3 will give us what? 3 times 3, 9, times another 3, that's 27. So 3 to the power of 3 will give us 27. 27 times 2, that will give us 54. So we have this to be 54 x, the y to the power of 3, close bracket, the plugs. Then we come to the last term here. Every tier will give us 1. The 3 to the power of 4 will give us 81, because that will give us 3 times 3, which is 9, times 3, 27, times 3, which is 81. So we have here 81 y to the power of 4. Good. So from here, what we do here, it is easy now. We can now use our coefficient to open up this bracket and get our final answer. Okay, so, all right, so let's go. So from here, we have all this. Oh, sorry. Yes, 81, please. Yes, 81. It's 81. Pardon? Okay, so let's get our final answer from here now. All right. So the first term here, we just keep this guy to give us here 16x to the power of 4 plus. So 4 times this will give us here 96. So we have 96 x to the power of 3, then y plus then 6 times our 36 here, right? Okay, 6 times 6 will give us 36. Then 6 times 3 will give us 18 plus your 3 will give us 21. So we have x squared y squared plus, okay, let's take, but let me rule this out so that you don't get confused with x. Okay, so we've done this, we come to this term here, so we use 4 to times this will give us 16, the 20, this times this will give us 16, then here we have 20, so 21 x y to the power of 3, then the last term here will give us here 81 y to the power of 4. Okay, so on this side, we have our expression. We have 2x plus 3y r to the power of 4. So this is the answer to this expansion, okay, using the Pascal diagram or triangle to get the coefficients alongside with x. All right, so this mark the end of this class, but I'm going to release another video again. When you have the power up to 10, 12, or 15, and in here you have a minus sign, what do we do? Or how do you expand that? So stay connected because I'm going to release another video on this simple expansion method and how to get your Pascal diagram to get the coefficient for each of the terms. Okay, remember this is All I Maths TV, and you know what, I love you so much because you are the reason for the existence of this channel. Again, stay connected and do not forget to subscribe if you've not subscribed. Okay, yeah, we roll out more challenges. I love you. Bye for now.